Hello students. We already know that image formation is characteristic feature of all mirrors, whether plane or curved. And we know they both form different types of images. But students, if you are asked to represent image formation by mirrors in your notebook, will you be able to do it? Yes, we can do it by ray diagrams. But for that, we have to learn certain rules. So in this video, let us see these rules to represent image formation by spherical mirrors in the form of ray diagrams. Let us see rule 1. A ray parallel to principal axis after reflection will pass through the principal focus in case of concave mirror. In case of convex mirror, we know it is a diverging mirror, and so reflected ray will diverge from principal focus and it should be extended back to meet at focus behind the convex mirror. Now question will arise that why all parallel incident rays pass through focus? We can answer this question with the help of laws of reflection. For that, first draw normal at the point of incidence on the surface of the mirror. Yes, normal means you have to draw a line at 90 degree. This normal, if you extend, you can see that it will pass through center of curvature. Now you already know that angle between incident ray and normal is angle of incidence. As per our law, angle of incidence should be same as angle of reflection. So draw a reflected ray with the same angle as of incidence. You can see it will pass through F. So if an incident ray is parallel to principal axis, it passes through the principal focus after the reflection. Now let us see rule 2. A ray passing through the principal focus of a concave mirror or a ray which is directed towards the principal focus of a convex mirror. After reflection, it will become parallel to the principal axis. To understand this behavior, just like in our previous case, draw the normal at the point of incidence on the surface of the mirror and draw a reflected ray with the same angle of reflection as that of angle of incidence. Because we have to follow laws of reflection, you can see it will become parallel to the principal axis after reflection. Thus, we can say that if an incident ray passing through focus gets reflected and travels parallel to principal axis. Now let us see rule 3, which says if an incident ray passes through the center of curvature of a concave mirror or directed in the direction of center of curvature of a convex mirror, it will follow the same path from where it has come. In this case, you will observe that normal and incident ray are overlapping because both are passing through C. So now what will be the angle between incident ray and the normal? That is, what is the angle of incidence? Yes, you are right. It will be 0. So as per our law of reflection, the angle of reflection should also be 0. That means the direction from which incident ray was coming, the reflected ray will go back in the same direction. Now let's see the last rule, that is rule 4. A ray incident obliquely to the principal axis towards a point P, which is pole of the mirror, on the concave mirror or a convex mirror is reflected obliquely. That is, the incident rays and the reflected rays follow the laws of reflection at the point of incidence, that is P. So they make equal angles with the principal axis. Here in this case, as you can see, our principal axis is itself a normal, because we already know that principal axis is always at the 90° to the mirror at its pole. So after the reflection, reflected ray will make the same angle as the angle of incidence with the principal axis. Thus, a ray incident at pole of the mirror gets reflected along a path such that angle of incidence is equal to the angle of reflection. So students, let's quickly revise all our rules together. First rule says if an incident ray parallel to principal axis passes through the principal focus after reflection. Second law says if an incident ray passing through the focus gets reflected, it will travel parallel to the principal axis. Third rule, a ray passing through the center of curvature is reflected back along its own path. And the fourth rule says a ray incident at the pole of mirror gets reflected at the same angle as that of the incidence. So students, we now already know the rules of representing ray diagrams. And we know that spherical mirrors form different types of images when object is at different location or position in front of the mirror. Now, how does it form these images? And what are the characteristics of those images? We will see in our next video. And we will also represent them in the ray diagram. Till then, thank you.